Now, having derived the marginal utility that Danny's getting from each additional muffin or each additional coffee, and you can see them now on the table to the right of our text here, we're in a position to begin to kind of monetize his pursuit of satisfaction in the marketplace. And by that I mean, in order to get the utility from the muffin or from the cup of coffee, he actually has to purchase it. And so we can begin to look at the utility that he's gaining as almost like a return on investment calculation. I'm going to put $4 into a muffin in the hope that it's going to bring me more or positive satisfaction. And all other things equal, if I'm motivated by economic outcomes, I'd rather get more satisfaction per dollar invested than less. And so we're going to try and take a shot at converting marginal utility into a calculation known as marginal utility per dollar invested. And very simply, we're literally going to take the marginal utility per that we calculated before per muffin or per cup of coffee and divide it by that coffee's price or that muffin's price. And that then is going to allow us to look at our budget in terms of allocating dollars to the products that give us the most marginal utility per dollar invested. It's real simple to do. Once we have the table here, once we've begun to calculate the marginal utilities, again, I know that I'm going to get 60 utils right here from one muffin, but I also know that I have to invest $4 for those 60 utils, meaning for each dollar I invest, I'm going to get 15 utils. Over here, Danny, who seems to like his first cup of coffee, is going to get 80 utils from it. To do so, he has to invest, he has to spend $2. Each dollar essentially is going to deliver 40 utils of marginal utility. For that second muffin, now we see that we're decreasing in terms of marginal utility. It's only 48 now. I still have to invest $4 to buy it, meaning each dollar essentially has a return of 12 utils for the dollar invested in a muffin. Here, we've got 24 utils for the second cup, which costs $2, or again, 12 utils per dollar. Here it's 40 divided by the $4 he has to spend for it, or 10. 8 divided by the $4 he has to invest in the muffin to get those 8 utils, or 2. This is going to be 0.5. Here we've got 0 divided by 4. There's no satisfaction from that sixth cup of coffee, no marginal satisfaction or utility. And here, where it's actually turned negative, we've got a return of -2, or marginal utility per dollar invested in muffins. Over here, that third cup of coffee delivered 22 utils, $2 to buy that cup of coffee. 22 divided by 2 is 11. 20 divided by 2 is 10. Here I have to invest I have to invest $2 to get a cup of coffee that only delivers one marginal unit of utility. So 1 divided by 2 is going to be 0.5. We've turned negative here, -1.0, and here that seventh cup has really done Danny in. -10 marginal utility, $2 per cup. That means there's a -5 util return per dollar invested in a cup of coffee. So again, nothing magical here other than trying to monetize, if you will, this concept of utility. So we're going to take marginal utility for each product and divide it by its price to come up with essentially the return of utility for each dollar invested in that product. Now, to finish off the problem, what we want to do is really take 2 steps to put together the primary assumptions we have to meet. First of all, we want to apply what's known as the law of equal marginal utility per dollars to come up with combinations, in our case, of muffins and coffee, such that Danny cannot better himself by exchanging a cup of coffee for a muffin. And that will only occur in situations where the marginal utility per dollar is equal. Because at that case, in those cases, Danny cannot better his position by investing $1 or additional funds in either one product or the other. The marginal utilities are equal, and therefore they provide the same utility, marginal utility, for an additional investment. So what we want to do first is identify those bundles, and then what we're going to do is go through and figure out how much each of those bundles that satisfy the law of equal marginal utility per dollar are going to cost, because the second constraint we have to meet then is whether or not we have enough money in our budget to buy the combination of goods. If we do that, we're going to go through our table and analyze marginal utility per dollar invested for muffins and marginal utility per dollar invested in coffee, and look for things like this. Because if I were to buy 2 muffins and 2 cups of coffee, it would put me in a position where the dollars invested in either products at the margin are exactly equal. And I would not be able to better myself by investing in one or the other. I'm at actually a point of indifference between the 2 products. And I'm going to look for other pairs like that. So a combination of 3 muffins and 4 cups of coffee both demonstrate equal marginal utilities per dollar. Again, points of essentially indifference. And if we look, we can see that we've got one more that we want to deal with here. And that's going to be 5 muffins and 5 cups of coffee, and who needs lunch or dinner after that? But nonetheless, in those cases, all of these are at that point of indifference where the marginal utility to be derived by an additional investment in either one of the products in these bundles, in these combined bundles, is not going to do anything for me. So we want to see then which combination is going to allow us to maximize our total utility while also allowing us to spend as much of our budget as possible without going over. So let's take a look now and see how much it would cost us in terms of our available dollars to purchase any of these 3 bundles for which marginal utility per dollar spent is equal. So we could start out by looking at the first bundle that we identified. Marginal utility per dollar spent is 12 for each, and so that would involve purchasing 2 muffins at $4 each, and also purchasing 2 cups of coffee at $2 each, which would allow us to spend 8 plus 4, or $12. Now, I know I can do that. I've got $30, but I also know if I only spend 12, I have $18 left. So clearly I could purchase more of either coffee or muffins or both and increase my total utility. Okay, so we can take a look at our next bundle where we can get equal marginal utility per dollar spent of 10. That would involve, in this case now, purchasing 3 muffins, again at $4 each, along with 4 coffees at $2 each. Now, if I were to do that, I'd be spending $12 on muffins, and I'd be spending $8 on coffee, or a total of $20. I could go forward and purchase another combination. In this case, the combination would be of 5 muffins at $4 each and 5 cups of coffee at $2 each. And that would mean I would be spending $20 on muffins, $10 on coffee, or lo and behold, I would be spending $30 in total for a combination of goods for which the marginal utility per dollar spent is equal, meaning I'm indifferent in terms of exchanging one for the other. I cannot improve my utility by purchasing an additional coffee at the expense of a muffin or vice versa, and I've spent exactly my budget. And that's going to be an optimum result that will result in maximizing total utility subject to the scarcity constraint of my budget constraint.